Some of the ways that we can make this humus, or at least some of these humus-like materials, is by doing composting. And I know many of us have been around parents or maybe grandparents that come from a different age where they save everything. My grandparents are like that still to this day. They will save their eggshells and their banana peels and their fruit peels and all these other different things, and then they'll add them to the garden in order to improve the soil quality. We want to do like maybe some vermicomposting is something you might hear. Just a couple of different phases of that thermophilic composting. Not that you'll need to know this, so there's no need to write that down in the notes if it's in there. But just to understand that this thermophilic is going to be this kind of heating of that compost material, and that is going to be beneficial for killing some of the diseases or some of the bad things that are in those soil, the microbes and whatnot, that are going to cause us issues when we put those into the garden. So again, the benefits of that compost are going to be changing that carbon to nitrogen ratio. And so the lower the carbon to nitrogen ratio, the greater the mineralization and the availability of that nitrogen to the plant. As I mentioned before, we're going to get this sterilization and detoxification and also disease suppression, because we're going to kind of basically bake that. If you've ever seen a compost pile early in the morning, you can start to see that heat coming off. And it's not like a fire, but there's enough energy that's being transferred there that we're starting to kind of bake or cook off some of that material. Some of these diseases and other bad things that might be in the soil, we're just kind of baking those off and breaking that down. And so that as our temperature increases, we're also going to increase the biochemical reaction rate. All right, so moving into kind of some of the factors and the practices, it's good to understand that there are going to be differences among the soil orders. So if you can remember back to when we did classification, this is where the soil orders come into play. And so that if I have an insectisol, I am not likely to have a lot of organic matter. Remember, these are our youngest soils, and so they just haven't had any exposure. There's not a lot of organic matter or an O horizon moving into an A horizon. And remember that our histosols are going to be like 20% or greater organic matter. So these are going to be like our peat bogs. And that those plant materials have just decomposed over time and they become stable. And so the biggest factor that's going to influence this is going to be climate. And so that in a little bit cooler temperatures, where we can expect there to be a greater organic matter. If we have more moisture, we can expect there to be greater organic matter. But if we have high temperatures and low moisture, then we will not have a lot of organic matter. So when I think about this climate, I want you to think about Arizona and how much organic matter you would think is in those soils. Probably not a lot, because they don't get enough moisture and they don't grow enough crops. And so if there's not a lot of crop growth and then decomposition, you would have low organic matter. Now I want you to think somewhere, let's say Kentucky or maybe Virginia. So we have a little bit cooler temperatures. We have a lot of moisture that comes, in the eastern United States, and that means that we're going to have greater organic matter. So that as our temperatures increase, we're going to increase that biochemical reaction rate, and they're going to break down this organic matter. Those microbes will use that as energy. Going with our texture and our drainage, this is going to be where water comes into play. And so that if we have a finer textured soil, we would have greater micropore space and likely to have a greater water holding capacity. And we just determined in the previous slide that if you have more moisture, you're going to have more organic matter. So in a sandy soil, you are likely to have less organic matter because the water is going to move through that soil profile very quickly. Some other management practices are going to be how much nutrients that we put in, how much crop removal that we do. So if we remove the crops, we remove that carbon, we remove those nutrients, and now those microbes are left with just what's in the soil, which is not likely to be enough. And then if we till our soils, we're exposing that organic matter to more oxygen. And when you expose carbon to oxygen, you get carbon dioxide, which is the opposite of what this climate smart agriculture is trying to do. These next couple of slides are just going to kind of give you an idea of some of the practices that you could use, or some of the results of these different practices that improve soil organic matter. So there's a lot of research being done on this long-term effects of this different crop management systems. And so here in University of Illinois, they had this cropping system, and they found that crop rotation produces greater soil organic matter than continuous corn. And so notice that we kind of go from medium carbon to nitrogen ratio. Oats probably have a higher carbon to nitrogen ratio. And then this clover is going to have a low carbon to nitrogen ratio. So they're putting enough carbon there, then they're providing the microbes some material that they can decompose quickly that allows them to decompose these other carbonaceous materials. So crop rotation is going to improve soil organic matter. In England, this Rothamsted experiment station is kind of one of the oldest experiment stations for agriculture that we have. It was done in like the 1840s, 1850s. They've done long-term studies, and they found that if they add manure, then there will be an increase in soil organic matter. So that as they're putting, when you got to think about what comes out the backside of an animal, it's going to have a lot of nitrogen, it'll have some carbon, but that as you increase that organic material into your soil, organic material increases soil organic matter. Duh. Okay, so what they did is they applied this they applied this manure for 20 years. Then they stopped it. And they stopped putting the manure on there, and they still had a positive effect 100 years later. Now, I don't know that many of us are going to, put this, adding these manure applications for, 20 years and then, another 40 years after that. But that as you add manure, you are going to increase the soil organic matter, and that's going to have a positive effect down the road. So that as we're starting to talk about soil health, when we go back to that regenerative agriculture graphic, integrating the livestock is where the manure comes in, and that manure is going to increase the soil organic matter, and increasing that soil organic matter is going to have a positive effect on our regeneration of that soil. So we need to make sure that we're applying organic materials to make sure that our soil organic matter is appropriate. Some of the different things that you can apply. We definitely want to put our cover crops down to protect that soil. They also add back organic matter because these cover crops are going to not only protect the soil, but they're going to pull in some, they're going to extract or scavenge some of the nutrients from that soil over the fallow, kind of over the winter. And then when you crimp those in the when you crimp those in the spring, they'll decompose and add those nutrients back to the soil. So it's kind of like a recycling system. So one thing to understand about soil organic matter is that it is not a consistent value across. It's not consistent across across the whole country. So, looking at this, we can see that 1% organic matter in a sandy soil in a warm climate is probably considered very good. Mainly because remember that we're going to, as that temperature increases, the biochemical reactions are going to increase. So greater microbial populations, greater decomposition. So we're going to, plus it's a sandy soil, so there's going to be a lot of oxygen that can make it into that soil. The pore space is going to be great. And so this is probably considered good. Like in Mississippi, if you can have 1.5% organic matter, you're doing really well. If you have 1.5% organic matter in Tennessee, something's wrong. You're not doing something right. So it's not consistent across. It's really kind of relative to the region that you're in. So 1.5% organic matter in a cooler climate like Tennessee or Kentucky, that would not be considered good. So it's kind of variable. It just depends on where you are in the country. If you were in Arizona and you had 1.5% organic matter, that would probably be amazing because they don't have a sandy soil, warm climate, no water. So to have 1% organic matter in Arizona, you would probably be doing some things very well. All right, so when we talk about this, managing this soil organic matter, ultimately the goal is to minimize nitrogen loss. And the three main losses for nitrogen that you're going to want to minimize are leaching, runoff, and volatilization. So this organic matter is going to adsorb, with a D, more of this nitrogen as ammonium or even nitrate with our anion exchange capacity. It's going to increase our CEC, which if it holds on to those cations, the plants can then take them up, and we minimize these losses right here. This kind of makes sense. The more plant growth that you have, you would expect to have greater soil organic matter because those residues are breaking down and being added to that soil organic matter, the whole component of soil organic matter. So this gets into nutrient management. So as we move into Module 3, just keep in mind that soil organic matter is going to play a huge role that we don't really address in our nutrient management. And as I've mentioned before, that as we till, we're going to accelerate organic matter loss because we're exposing that carbon to carbon dioxide. And so if we're doing these things and we're adding carbon dioxide to the atmosphere and not taking them out, then we are kind of defeating the purpose of what plants are intended to do. And so kind of getting into, the greenhouse gases that we release, whether it be carbon dioxide, we have nitrous oxide, methane, they all want to point the finger to agriculture and say, agriculture is causing the problem. But if you look at this graphic, agriculture is actually the lowest on the totem pole, or, the least, has the least contribution to greenhouse gases. But we're not going to stop driving, and we're not going to stop producing electricity. Industry still has to make goods for electricity and transportation and people to consume, and then also people need places to live. So none of these things are likely to change, and so the only thing left is agriculture, and they want to look to us as if our 9% reduction is going to kind of change, global warming, global climate change, whatever you want to think about. We're the only thing that they see that can reduce the inputs, but we also have the lowest input. One thing that's interesting about this particular graphic, when COVID first hit This was, March of 2020. I think if you go back, you can probably look this up and look for a satellite image over Beijing, China. And the satellite image over Beijing, China, you couldn't see the city because of all the smog, of all the industry, of all the transportation, of all the people living there. You couldn't see any of that because think about Los Angeles as well, right? A lot of smog over that because it's a dense area, densely populated with a lot of traffic and a lot of human. There's just a lot of humans there. So COVID hit. Everyone stopped going outside. Everyone kind of basically stayed inside. No one was driving buses. No one was driving cars. No one was doing any of this other stuff. And slowly but surely, the smog started to lift. But there wasn't any change in the agriculture sector because agriculture is not really putting that much into this global climate change that they think is. Sorry, that's my little soapbox for that. But we're going to get pointed at. They're going to want us to reduce these emissions. They're going to want us to do our part. Not only do they want us to reduce the emissions that we have, they also want us to absorb, or kind of reduce some of the impact of their living styles, right? They want agriculture to remove some of the carbon dioxide from transportation, from electrical production, fossil fuel combustion of industry. They're looking to us to kind of filter out their atmosphere. And yet they want us to do more with less, and they also want us to, fix their problems. The beatings will continue until morale improves. Oh, other way. All right. So just a few other sources. We're going to have this methane that is going to be produced by cattle. We kind of can't stop that, right? They're eating grass. They're eating and consuming, and they're producing this methane. And so this is where some people will want to kind of go to a more crop production based system because they believe that taking out animals will minimize the impact of methane. And then also this manure. I don't really see this happening. Too many people like meat. Our fertilizers are going to have some, impact. If we apply nitrogen fertilizers in the wrong scenarios, we're going to reduce. We're going to actually give off this N2O gas. We'll talk about this in the next module, in module 3, when we talk about the nitrogen cycle. So they want us to produce more crops with less fertilizer so that we can minimize the impact of N2O gas being given off into the atmosphere. And they want us to improve crop production so that we can remove carbon dioxide, but we can't do it with fertilizers. And plants need two things in order to grow: water and fertilizer. So stop applying fertilizer, stop applying water, grow your plants better. Only 9% of you're only 9% of the problem, but we want you to do more with less and fix the problem. Kind of the plight of agriculture. And then finally, that this graphic shows that we are increasing our carbon dioxide concentrations in the soil. In the atmosphere. They're wanting us to use soil as a means to trap this carbon dioxide. Because remember that the total soil carbon is greater than all the plant and the atmospheric carbon dioxide. It has the propensity and the ability to retain that. So they want to figure out how to get carbon dioxide out of the atmosphere into the soil and be stored there. That is kind of my take on the basic premise of climate smart agriculture. All right, that is ending module 2.3.1. We'll move into and that is the end of module 2.3.1. In the next module, we'll be discussing microorganisms and their role in carbon sequestration and the decomposition of those plant materials.